Okay, welcome everyone. Welcome to this afternoon's webinar on retrofitting your home, the why, the how and the when. So this webinar forms part of the Energy Awareness Week at NUI Galway and the Engineers Ireland Engineering National Development CPD series. So my name is Jamie Goggins and I'm the Professor of Civil Engineering at NUI Galway and I'm a member of the West Region Committee. So a huge thank you to the students in particular in the Energy Society and the Community University Sustainability Partnership within NUI Galway, who put on a lot of events this week to raise awareness of energy across campus, but in the broader community. And also to the Engineers Ireland West Region Committee for organising this webinar series on engineering the national development. So it's based around Project Ireland 2040, which is the National Development Plan. As I said, the focus of this afternoon is on retrofitting your home. So the why, the how and the when. So we're going to try and answer those questions. So delighted to have two panelists joining me this afternoon. So Dr. Paul Moran is a postdoctoral researcher in the MaREI Centre based at NUI Galway. He holds a BE in Energy Systems Engineering and a PhD in Engineering, both from NUI Galway. He investigated the environmental, economic and social impacts of residential buildings in Ireland as we move towards nearly zero energy buildings as part of his own PhD. And he's worked on various different projects, collaborating with engineers, scientists, architects, social scientists, and so on, to try and better understand the interrelationships between the operational energy demand practices in buildings, the people occupying those buildings, and the materials and technologies used in the construction of the retrofitting the buildings. Also joined by Dr. Asit Mishra, who's a postdoctoral researcher in the School of Engineering in NUI Galway. His research focuses on optimizing indoor conditioning energy while improving occupants' indoor experience towards comfortable, healthy, smart, low energy buildings. So his interests include indoor air quality in healthy, low energy buildings, occupant thermal comfort, HVAC systems, IoT in the built environment, and so on. Unfortunately, Orlaith McGinley, who's a PhD student in the MaREI Centre for Doctoral Training based at NUI Galway, is out sick today, so she can't join us. And I better apologise for myself as well, a bit croaky today. And there might be some background noise around here because the children are at home in midterm and I'm at home isolating. But hopefully everything will go okay. So we're going to use Slido today. So if you haven't used it before, this is a great tool to be able to, so we can interact with you. It's unfortunate, we like to be in person to be able to interact, but because we're online, we find that this is a good way to interact. So if you could go onto your phone or your laptop there, and if you could open up slido.com, so slido.com, and if you put in the hashtag MaREI, so MaREI is MaREI. If you put in the hashtag MaREI, then you will get into the event. We'll have a number of questions there. So just to see if it's working in there for you. So if you go on to slido.com in there, and if you put in the hashtag MaREI, MaREI, and the first question that we're asking here is where is everyone joining us from today? So that'll just give us an idea to see if you can, if it's working, if the Slido is working for you, and also just an idea to see where people are at the moment. Very good. So you see it's a word cloud here that we have. So the more more times a word is typed in by the different participants, obviously the bigger the word can get. So there's a big fight here between Galway and Dublin. So it looks like it's neck and neck here between Galway and Dublin. Yes, Galway are ahead by a neck against Dublin. Oh no, Dublin are coming back. It's level again. In there, Cork now are represented in there along with Kildare, Drogheda, Portlaoise, Scotland, Westport, Mayo, Mullingar, all the way around, all the way to Dunboy, Gort, Meath, Dunboy, Uachtarard. Oh no, Dublin's taken over. Dublin's ahead. We've got 40 people in there, so there should be, hopefully we'll get more in there. I think there's about 100 and odd people online here at the moment. So just see if a few more you can get on to slido.com. And if you type in MaREI, that's the hashtag MaREI that will get you into the event in there. So we've got about 50 people in so far on it. So that's about half the participants. So it'd be great if we could get a few more people into the slido.com. Okay, so as you're just getting on there, so it's great. So we're neck and neck. I better move on. It's level between Galway and Dublin, so we'll move on, and Cork is coming up slowly behind that as usual. Okay, so I'm going to hand you over to Dr. Paul Moran, who's going to talk through the various the why, the how, and the when part of of this webinar, and he'll interact with you also through slido.com. Okay, over to you, Paul.
Thanks, Jamie, and thanks everyone for attending today. So I have a couple of questions just to, again, keep the interaction going between everybody. So Jamie, if you move on to the next slide. So what does retrofitting your home mean to you? Comfort, big one already. It's great. Expense, okay. Reducing, yeah, okay. Warm home comfort, better indoor air quality. Comfort seems to be the big one that's coming through. Weather resilient, improve energy efficiency. Savings, energy savings. Yeah, I think everybody's kind of hitting the key aspects that we're associating with retrofitting, so everybody seems to have good knowledge already. Lower energy, lower bills, reducing costs, yeah. So next question, do you feel thermally comfortable in your home? So I'm in my apartment here in Galway. I'm on the 4th floor. It's right beside the sea. It's kind of chilly. There's a lot of air infiltration today. So okay, people seem to be in between or on the positive side of things, which is good. So, are you conscious at all about the energy that you use in your home? This is always an interesting one to get people's opinions on. It always ranges.
I guess that was a bias thing because people who are conscious would be attending the seminar. It's more likely.
Yes, of course. I should. Yeah, you're right there.
I mean, all of this is anonymous, so you don't really have, you can give your free and frank opinion. You don't have to be on the majority side.
Okay, so why do we want to retrofit our homes in Ireland? So as we probably are all aware, there's around 2 million houses within the country, and about 1.7 of them are occupied. So that's going on 2016 census data. So of course that might be changed by now. So what's the kind of split that we see in our housing? So around 42% of our houses are detached, around 20%, 28% are semi-detached, and then we have around 17% that are terraced. And then for apartments, we're coming in around a low 12%. And as you look at our kind of construction periods, you'll see that, as we know, a lot of construction went on in the early 2000s before the economic crash, and then kind of dropped afterwards. Then in terms of our building regulations, I suppose, they only started to come into the country from the late 70s onwards, and of our buildings that were constructed prior to then wouldn't have had any sort of energy efficiency associated with them from a standard point of view. And then that's kind of been consistent across, the world and Europe. So our buildings require a lot of energy for them to operate. So Jamie, if you want the next slide. So how does that energy break down for the Irish housing? So here I have a Sankey diagram, if I remember off the top of my head. So essentially what we're showing here on the left-hand side is the fuel sources that provide our energy inside our homes. And on the right-hand side, the breakdown in terms of the energy use. So as you can see, our space heating and our water heating account for nearly 70% of our energy uses inside our homes, with the rest broken down mainly for our lighting, our appliances, and then for the cooking and others. So for space heating particularly, it's kind of really been driven by our oil usage and our gas usage and from our solid fuels. So obviously this is a pretty high energy demand, and to try and reduce the amount of energy that people were using in buildings and to kind of help people become more aware, the EU introduced legislation whereby we had to introduce energy performance certificates for our homes. So Jamie, if you move on to the next slide. So in Ireland, this energy performance certificate is known as a building energy rating. So the rating itself is on a 15-point scale and ranges from an A1 to a G. So for our new builds, when we're constructing them currently, the levels that they're required to meet generally come in at around an A2 of BER. And then for our building retrofits that have to undergo a significant or a deep retrofit now. So if they have 25% of the surface area covered in terms of the works that are carried out, they have to meet a B2 rating or else a cost optimal. Then in terms of kind of where we're at across the country, so nearly 1 million of those buildings in the country have had a BER carried out. Jamie, is there a diagram there? Yeah, sorry. So on average, our homes are at a C1 level, and of the 1 million homes that have had a BER carried out, many of them would be either kind of new builds or houses that got either retrofitted currently or are currently being rented. And then, so the remaining homes that have to be retrofitted or have to have a BER carried out, are expected to be on the lower end of the scale. So from kind of a C1 downwards. So we're expecting, as you can see, there's a lot of work that needs to be done kind of to get our housing stock up to the required B2 levels across the country. So where are we losing all the heat inside our homes if they're so energy poor? Well, here's just a typical 2-story detached house, and for a C1 rated house, we see most of the heat has been lost out through the walls through a combination of air filtration, the windows and doors, and the roof and the floor. That's where the rest of it is escaping then. So because we spend, I suppose, so long of our lives indoors now, how much of your life do you think that you spend in your home? So this will be interesting now, considering from COVID that a lot of people now are working inside their homes as well, a lot of the time. Okay, half people saying are 7%, which is the correct value, but that is, I suppose, based on research that was carried out prior to COVID. So that would be, it'll be interesting now to get an update on those figures themselves. So if Jamie, watch the next slide. So we spend around 87% of our life indoors, with around 70% of that spent inside our homes. And then we spend about 34% of our time then within our bedrooms. So because we spend so long of our time indoors, it's important that we have a good quality indoor environment, because our indoor environment, it's been associated with our mental ability. So in terms of our ability to learn, our ability to work, our ability to understand things, and then from a health perspective, so it's been associated with people's allergies, cardiorespiratory systems, and then as well just the actual comfort. So it can cause irritations on your skin and cause skin dryness as well. So Jimmy, if you move on. So how can retrofitting help? Well, it can help with all of these things. So retrofitting can help to improve the comfort levels inside our homes, so make them a lot warmer and make them more airtight, so they're less susceptible to any of the outdoor climate conditions. And while being able to provide both those things, at the same time, they're able to provide better ventilation through the systems that we're able to install. And then the low emission materials that we can then introduce as part of the retrofit solution can also help with the indoor air quality. So this will be an interesting one now. Has anybody had any retrofit work carried out in their home? Okay, so around 20% of around 30% of people have had some work done, 33%, a third of people. So 30 people probably have a good knowledge of this information already, but maybe they'll be able to correct me on some stuff. But if we move on to the how. So generally the consensus is in Ireland, the best approach is to go through a fabric first approach. So to insulate a number of our building elements, so our roofs, our walls, our floors, and then also introduce new thermally efficient windows and doors. And then once we kind of reduce the energy demand of our buildings, we could then start to look at upgrading our heating systems and also introducing some renewable energy technology. So in terms of our roof insulation, so we're able to install insulation in the joists of our roofs and in the rafters of our roofs, so in between either of them, and then along top inside the joists as well, on the joists as well. This is typically suitable for the majority of homes inside the country. And then the prices for this kind of work, it typically range from about 10 to 25 meters squared. That depends on the insulation thickness and then any additional extras that you need on top of that. So if you need ventilation, or if you want to put some storage platforms inside the attic itself, or if you want to insulate the tank up in the attic as well. So it can kind of range depending on kind of the current condition that your house is in, and then the kind of work that needs to be carried out. So then in terms of our floor insulation, so predominantly there's kind of two types of flooring that you come across in Ireland. So you could have a suspended timber floor. And then if you have that kind of floor inside your home, you can put your insulation in between your rafters, and then that's surrounded by an air tightness barrier and a vapor control barrier to help with any moisture issues inside the timber itself, and then to limit any ingress from air infiltration as well. Then for solid floors, this can be a bit more disruptive. So the timber flooring, it's a disruptive approach as well, unfortunately. And then for the solid floors, you can then put some insulation on top of the concrete floor itself, or you can also remove the concrete floor entirely and then replace it with a brand new floor. Now, unfortunately, they're all just kind of disruptive approaches, and the prices for this can vary significantly, again, depending on kind of what your home is like and the current condition itself, and how much the floor needs to be replaced, and whether you want to have some new flooring put into your house. So just for example, if you want to retrofit a suspended timber floor or put some insulation on top of the existing concrete floor that's already in place, you can have prices varying from 40 to 70 meters squared. This is kind of price and information that we kind of collected over the last while, but if anybody has any experience of this, that's on the call now and probably wants to maybe provide some other information, that'd be great. So if you want to move on. So for our walls, we have a number of different approaches that we can use to insulate our walls, but because we have such a diverse range of kind of external wall types inside the country, that's kind of dictates what we're able to apply to our homes. For the different wall types that we've had in the country, so from pre-1900s to the 1930s, we've seen a lot of solid stone wall constructions that were either plastered or unplastered, and then we can have solid brick wall types, so around 215 millimeters thick to 330 millimeters thick, and they would have absolutely no plaster work that's on the outside at all as well. So then as we move forward, kind of from the 1940s to the 1970s, different wall types kind of became more commonplace. So we had our solid and hollow concrete wall types, and then we also started to see empty cavity walls as well within Irish construction. Then as we move forward from the 1970s to the 2010s, so at this point, building regulations started to dictate that we were introducing insulation inside our different wall assemblies. Then as we kind of move forward and standards started to become tighter, the level of insulation on our walls started to increase. So originally we were maybe having 25 millimeters thick inside our cavity walls, but now this is moving towards having a fully fitted out cavity. And then from the 90s onwards, our timber frame housing as well starts to become a bit more commonplace on the Irish market as well. So for the different retrofit strategies that are available for our housing or for our walls, so we have external wall insulation that we can apply onto the exterior of our walls. So this is generally suitable for solid stone or brick, mass concrete, and hollow block and cavity walls. Now, the type of insulation and the thickness of the insulation and the material of the insulation, that's all kind of dictated by the house itself. So its location, what it's constructed out of. So the different materials are obviously suitable for different house types. So I'm probably not going to get into that today because unless we have it in the Q&A afterwards. But for now, we're just going to kind of give a high level approach or information. So for the prices that it generally costs to externally insulate your house, it's from about 120 to 150 meters squared. Then if we move on, so then the next approach we can have is to internally insulate our walls. So this is to insulate the interior of the external facade on the inside. So again, this is suitable for a range of different wall types. Again, referring back to the type of material that we're using and the thickness of the material they're using, it's kind of dictated by the wall that's inside your home. So we have to deal with it from a thermal bridging perspective. We have to account for moisture risk. So the type of system and the materials that we use are all dictated by that. So the prices, they can generally range from, I can't see that right now, so the blackness on my screen, but it's generally lower than I think it was from 70 to 100 meters squared, if I remember off the top of my head. And that's kind of less than our external approaches, but then the internal approaches is a bit more disruptive because we have to account for floor inside our houses, obviously, and then if we have any kitchens or anything that's against the walls, we have to be able to build around them. So it's a bit more disruptive than an external. And then it's a bit harder to deal with thermal bridging and moisture risks in that sense, unless we have very quality high level detailing in place. If we go on to the next slide. So for our cavity wall insulation systems, our cavity wall types, we can pump it with polystyrene beads, for example. And so depending on the level of insulation that's already in place inside the cavity, we can pump it up fully, and then it also might be empty. So again, we might completely fill it up altogether. Those prices that are there is a typo. I mustn't have. That's an incorrect value. So that can typically range from about 10 to 15 meters squared. Unfortunately, I have a typo there. Then for our windows and doors, we can introduce either double or triple PVC, UPVC, timber, or aluclad, and ranges for them per meter squared can generally range from 350 to 450 meters squared. So move on to the next slide. So then once we kind of get our building fabric improved from a thermal sense, and also while also considering all the moisture risks that are involved, we then have to make sure that we have our home well ventilated to provide good quality indoor air. So there's kind of two strategies. So we can have our wall vents, so they can either be passive or mechanical. And so for passive wall vents, you generally have to kind of rely on yourself to open and close them at times. Well, generally you're meant to have them open at all times, but I know some people close them because the wind can then start to kind of be driven in and kind of cause breeze inside the homes. So I know when I've seen people have closed them, so it kind of disrupts the indoor air quality. Then for our mechanical kind of approaches that it can be applied inside our bathrooms or inside the kitchens to kind of remove any moisture inside those homes. So for vent in that sense, kind of generally ranges from 50 to 150 euro. But then we can also introduce a mechanical ventilation system. So those ranges from about 4,000 to 9,000. That's kind of dictated by, the size of your home, the amount of wet rooms inside your home. And that's an automatic approach rather than the manual approach with the other systems. So that is able to provide a much more high quality indoor air inside the homes because remove any air pollutants, and it can be able to detect CO2, so it can remove any of those issues, and it can also deal with any humidity issues on an automatic sense. So move on. So for our heating system upgrades, so if we want to introduce any heat pump system, so here I've just kind of highlighted air to water and ground to water, which are different approaches, but there's other approaches as well that are on the market. So for such as exhaust air to water, those efficiencies, so they have a very high, so from 200 to 400%. Now that's dictated as well by a lot of things. So that's why you need professional to be able to install them properly, but those costs are generally high. So from 8 to 20,000, now that's dictated by the cost of the unit itself and whether you need to replace any radiators and etc. Then you can also introduce our oil or gas boiler, so to either upgrade kind of the system that you already have in your home. So now the efficiencies of those are a lot less than the efficiencies of the heat pumps, but their costs are a bit less. But when we move on to the grants, we'll see that the grants for the heat pumps are available, whereas they aren't for the gas and oil boilers. So when we're talking about kind of the range of prices to be able to get our homes up to different energy performance levels. So for our detached houses, we'll see kind of get them up from a G to a D1. So to the different energy performance levels kind of requires different investment levels. So for our detached house here, we can generally see from an investment of 15 to 50,000, depending on kind of the level the house is already at and the size of the house, we can get it up to a C2 to a B3. Then again, for different ranges of our sizes of detached houses, it can either take 35 to 75,000, kind of get it up to a B2 and A3 level, and then from 45 to 90,000 to an A1 to an A2 level. So that's kind of based on all the prices that we've been able to collect together so far, and based it on about 32 different biology types, kind of going off the Tabula study that was carried out years ago. So now that's based on the information that we've been able to collect. So if anybody has any other experience based on those kind of figures, please feel free to add it in the chat or to comment on it afterwards. So Jamie, if you want to move on there. So there's a couple of different approaches that we can go to get our houses retrofitted. So we can carry out all the work at once. So to get for a house example from a G rated or an E rated house all the way up to the standard that we want to get it to. So carrying out all that work at once. And then the next approach is to kind of get it from, so obviously looking at the price that I showed in the previous slide, it's a big investment. So people aren't able to kind of carry out all that work at once. So we can split that up into different stages. So you can focus on the fabric first and then kind of introduce some of your renewables and then maybe introduce your heat pump then. But while you're doing that, it's important to make sure that you have a good plan in place to make sure that when you're introducing any of these measures at different stages, that you've accounted for that in your entire plan to get from, for example, from your E-level house to your A2 level house, that when you're doing your work in stages, that when you then move on to the second phase of your work from the first phase, that any of the work that you carried on the first phase won't cause any issues with the work that you carried on the second phase, etc. So professionals involved in this entire process to make sure that the plans you have in place to get your home upgraded to a good energy performance level are the correct plans. So if we want to the next slide. So as part of this is why one-stop shop services are great. So from a client or from a homeowner point of view, if you're to kind of look after all this work on your own, you're going to have to deal with contacting a load of different stakeholders within the retrofit side. So from energy auditors to retrofit designers to manufacturers, suppliers, contractors, as well as trying to finance or sort financing for the work itself. So rather than having to kind of look after all that yourself, when you go through a one-stop shop model, you're able to have a single point of contact who is then the only person that you deal with, who is then the person that you talk to answer all your questions regarding this. And then in the background, they are able then to communicate with the finance side of things, with the energy auditors, and with all the different people that are in place. So the multiple benefits of the one-stop shop model. So it can help you with your decision-making throughout the whole process, and it gives you tailored advice. And then because you're able to then work with all these different stakeholders that are all under the one umbrella of the same service, you're able to then get a lot better quality service. So improved trust, so it reduces the stress and the hassle of the whole thing. And if they're able to again sort out all the financing side of things for you. And then overall, this helps to increase the householder satisfaction levels with the buildings or with your retrofits. So when should we do this at work? So there's a massive challenge to get all our houses up to the required levels that we need to get to. So the government has set a target of retrofitting 500,000 homes by 2030 up to B2 level. or cost optimal at least. And this equates to about an average 50,000 homes every year. So how are we going to be able to, or what supports are kind of in place to be able to achieve this? So to get to 500,000 homes by 2030, as I was saying, requires 50,000 homes a year. What's this equivalent to in terms of population of different areas around the country?
So do you think there's 50,000 homes currently in Castlebar, or 50,000 in Galway, or 50,000 in Cork, or 50,000 in Dublin? So that's the question that we're trying to ask here, just to put in context of what 50,000 homes per annum retrofitting means.
Okay, so about half people guess Galway. The correct answer is Cork. So if I remember off the top of my head, Jimmy might correct me. I think there's a population of about 33,000 in Galway, and then a population of about
not a population now, number of homes. It's about,
oh, sorry, yeah, number of homes. Sorry,
there's an average 2.6 people per home. So 33,000 homes in Galway or so. There's about 50,000 homes in Cork, and I think all of Mayo together, not just Castlebar, would have about 50,000 homes, and maybe Dublin has over 200,000 homes, maybe 220,000 homes. So the 50,000 homes will be effectively taking all the existing homes in Cork and retrofitting them all in 1 year. Actually, at the same time, the government also has a target to build 33,000 new homes. So in one given year, it would be like taking all the existing homes in Cork, retrofitting them, and at the same time, building the equivalent amount of homes that you have currently in Galway. So that's a lot of activity in working on homes. Thanks, Paul.
Thanks, Jamie. So to support this, the government has a number of subsidy schemes to encourage homeowners to retrofit their home. So there's 3 different schemes that are currently being managed by SEI. So the first is a free energy upgrade scheme. So this is managed by SEI, and it's available to homeowners who are receiving social benefit, social benefits from the government itself. So job seekers, etc. I can't remember all of them off the top of my head, but one of my colleagues might introduce that information into the chat. So this is fully funded by the SCI, who manage the entire process for the homeowner. So this is available for homes that were constructed prior to 2006, and they offer different retrofit elements from insulation to heating controls and heating systems itself. So the next retrofit grant that's available is through a one-stop shop service. So this entire process will be managed by the one-stop shop itself. And this is available for homes that were constructed prior to 2011. And through all the grants that are available, this grant scheme can provide up to 50% of the works funded itself. Then for the last one, so this is an individual energy grant. So while it's able to fund up to 80% of the retrofit work itself, the entire process has to be managed by the homeowner. So they have to sort through all the application form work. They have to contact all the different contractors to organize all the work themselves. And as well as that, they have to be able to assure that all the measures that they decide to carry out, that they all make sense together, and that there won't be any issues moving down the line. Now they can get professionals involved to do that. And if they are going down that road, I really emphasize the point that they need to do that, because if they don't have issues later on down the line. So again, this is available for all homes that was constructed before 2011. And Jim, if you mind to the next slide. So here are the different options that are available to homeowners. So for the one-stop shop service, there's grants available for all the different range of retrofit measures. So you get your home energy assessment carried out, you get funding towards the project management side of things. Then you get funding for your roof insulation, your wall insulation, your floor insulation, as well as your windows and the doors. And then on the heating system upgrade side of things, you can get grants for your heating controls, heat pump, and all your renewable systems, and then for your ventilation systems as well. Then on the individual side of things, there are less options available for homeowners. So you're only able to get grants for your roof and wall insulation, and then for your heating upgrades and for your renewable energy upgrades as well. And then for the, so here are the range of different grants that are available for homeowners. So for the ranges that I've shown here, that's dictated by the type of house that you have. So for the high range, that's for your detached house. And then for your low side of the range, that's for your terrace type of housing, because as we've seen in the previous slides, the costs are kind of get lower as you move down from the different typology side of things, because you obviously have less walls that you're losing heat out of, so there's less work needed to be carried out on them. So there's also some lower numbers that are available as well for apartments, but I haven't included them because hope I'm not insulting any apartment deliverers here today, but I haven't included them here because the majority of people are living in a one-off family homes, so either detached, semi-detached, or end terrace. But the prices that are hit there, they're just a small bit lower for the apartments themselves. So considering all the grants that are available for the one-stop shop service, it's obviously a very attractive option for the homeowner. Whereas again, if you go down the individual energy side of things, you have to look after the entire process yourself. And if you don't do a good job on that side of things in terms of getting the right professionals involved and whatnot, that can lead to obviously issues to further down the line. Whereas if you go down with the one-stop shop service route, while it may work out that you're only funding about 50% of the overall cost, you have that quality insurance in place that whatever works that are being suggested by and carried out by the one-stop shop service, you know that they are providing a high quality service at the same time. And as well as that, they can help you map out your plan from where you are right now to where you want to get later on down the line. So that is obviously a very, very attractive option for homeowners currently. So between the grants that are available right now, as well as the other benefits that you see, so from the thermal comfort improvements, from your indoor air quality improvements, so from your as well as the savings that you're going to make on the fuels, the fuel costs of your home. So as we know, fuel prices are going up. Retrofitting really is a good quality option now for homeowners to move forward, because we have all the measures in place, and then we have access to all our financing that we can get in place now as well. So we have a few last questions. So what is the biggest barrier to deep retrofitting homes in Ireland, do people think? Cost, yep. Skills, yes, it's a big issue. We need to get more people trained up in the right skilled areas to be able to carry out this work. Rip off, that's an interesting one. I'd like to get some people's opinions on that one. Cost of supply, yeah. Disruption, yes, it's a big issue with a lot of homeowners. Hopefully through the one-stop shop, we can hopefully make that disruption a bit less to make so by being able to coordinate everything for them. So what do people think that we need to do, or what do people think the government need to do now to help people get to 50,000 homes per annum? Grants, make them more accessible, increase grants, interesting. Interest-free loans, yeah. Trading, yeah, so there are skill shortages to be able to kind of hit the levels that we need, because we also need to build our new homes as well. So those number of homes that we need to build. So I think it's in the 20,000s or the low 30,000s. So on top of the work that we need to retrofit as well, to get people to do all this work is going to be a big issue moving forward. So we need to train up the people. Yeah, so there's a lot of different issues that we need to get to be able to hit the kind of homes that we're aiming for. So thanks for all your feedback, and those are all the sources for all the slides. So thanks for all your interaction there, and if you have any questions for any of us here today, glad to be able to hopefully answer them. Thanks.
Thanks, Paul. It's fantastic. It's great to see the engagement. So we've had 130 odd people online. There's loads of questions here coming through in the chat in here. We've only got a few minutes left. I know I can see that Asit has been very busy answering questions, but so have other people as well, which is fantastic. Is there any there that you want to pick out, Asit, just to highlight?
Yeah. So there is one question regarding electric boilers and if they are covered under the grant schemes.
I don't believe they are, but someone might correct me. I believe it's only heat pumps that they're offering grants for now.
Oh, so there's a request to go back to the slide reheating systems and costs.
Heating systems.
There was a question regarding the MHRV, and if you have an MHRV, is it still necessary to have a separate air vent in rooms with fire or stove? So as far as I know, like even if you have MHRV, you will still need to have exhaust systems in your kitchen. I'm not sure about regarding the situation in your, like, let's say if you have a boiler, you still require a few exhaust for the boiler. Jamie, Paul, maybe you can correct me if I'm wrong here.
Yeah, I'm not sure the answer that one. So that's when you have a stove and a fire, that's for the carbon monoxide, and that you require ventilation in the room. So I just don't know the answer off the top of my head, whether if you have a mechanical ventilation system, whether you need an additional vent in there. Someone would probably know better than me that's online at the moment.
What I've seen from the Partic documents, you definitely you still require your exhaust ventilation in kitchen. I haven't seen, like, you still require exhaust ventilation in kitchen and wet rooms, like, in addition to your MHRV. But I'm not sure like what's regarding for the other kinds of heating systems. Okay. There was a question regarding PER is not very focused on air tightness, and air tightness could be critical for the efficient functioning of heat pumps. I believe the PER does not take into account air tightness, but a lot of.
Sorry, Asit, you're coming and going there, so it's hard to hear you. I can see some questions here around heat pumps and air tightness. I mean, so it's a fabric first approach that you need to take. You need to insulate your walls, your attic, your floor, make your building airtight, and then the heat pump then will come after. If you put a heat pump in and you have a very leaky building that a lot of your heat is escaping through infiltration or through the walls, then your heat pump is going to be working really hard and won't be very efficient. So heat pumps will work well if you've got a well insulated airtight building. But on the other side, then if you make your building very airtight, it's very, very important to have a good ventilation system in it. So a controlled ventilation system, because you imagine inside a volume, someone puts it inside a balloon and you're not, no air is allowed in and no air is allowed out. It gets very uncomfortable inside that balloon. So you need to be able to get the fresh air in into the space. So you have a good quality air within your rooms. And the best way to do that is using a heat recovery ventilation system. So a mechanical heat recovery ventilation system of some sort, so that when you're bringing the fresh air in from outside, and that you're using the stale air from inside, you're taking the energy from the stale air from inside to heat up the air as it's passing in, the fresh air. So the fresh air and the stale air don't mix as one is passing in and one is passing out. But what happens is it takes the heat from the warm air that's coming out of the rooms and taking that heat and putting it into the air that's coming in from outside. So that means that you get fresh air in from outside and not at the temperature that is outside, but at a temperature closer to what the current building is at. So that's important. So there's a few comments there about quality and so on in terms of retrofitting. Some issues that have been had in terms of pump and cavity walls because that cavity was there before to help control the moisture in a way, and making sure that you use the right materials that the walls can breathe, that the moisture doesn't end up coming into your building or on the inside of it. And that's a big issue in terms of making sure that you get good professional advice in when you're retrofitting your building, because we can do damage, significant damage to our own health and well-being in the buildings because we don't have good air quality in there, but also significant damage to the fabric of our building as well. So our walls need to be able to breathe. We need to be able to keep the weather out, but also allow them to breathe, the moisture to breathe correctly in them, and also obviously to need to be airtight. So it's putting the right membranes, the right barriers in there, the right insulation materials and so on. And Paul touched on that in his presentation, where it's the thickness and the type of insulation or the type of material to use is are very important. So this the one-stop shops. I see a few questions here around the one-stop shops. So SEI, can't remember if they have them up now. They weren't up a couple of weeks ago, but they basically have people that are registered as one-stop shops up on their platform. So they're not guaranteed. SEI don't guarantee the one-stop shops, but what they do is that they're one-stop shops that are registered with them. And then look, just be careful. Like obviously a one-stop shop, it's not a standard offering that everyone gives. So even though there will be a number of one-stop shops available to you, not every one-stop shop has the same are following the same standards or the same ethos. So just obviously have a look a little bit more closely to what the one-stop shop is offering, and getting those guarantees, I suppose, because you're going to one entity that's going to help you manage and and achieve your retrofit. So making sure you get the right guarantees there as well.
Jimmy, there is a question regarding historical buildings. Like, can they opt out?
Yeah, so
because of aesthetics.
Historical buildings need to be, a lot of care needs to be taken with historical buildings. So, like if you take cities like Dublin in particular, Limerick, Galway, but like Dublin and Limerick, that there are a lot of very important historical buildings in that. So trying to be sensitive to our historical buildings. So if there's a preservation order on our building, then it's limited on what we can do in terms of retrofitting. So preservation order is there obviously to make sure that we don't lose our historical past in terms of our building infrastructure features inside, both internally and externally. So a building that has a preservation, it's obviously a lot more limited in what you can do, but not all historical buildings have a preservation order on them. But even when they do, even if they don't, you have to be very careful of your solutions there, what you use. So very, very careful. So for example, dry line in the inside, making sure that it's a breathable insulation product, a breathable system that's there, because those historic walls are used to breathing. So they're used to getting, warmth into them to help them dry out. They used to be able to breathe and so on. So being very careful of what we use in historical buildings. And my recommendation there is for historical buildings, again, ask whoever you're getting, whatever profession you're getting, ask them if they have, what experience they have in professional or in historical buildings, and in particular the historical building type that you have that you're interested in, because you could end up doing a lot of damage and so on to the building in there. Will the slides be shared afterwards? Yeah, so the webinar is recorded, so the webinar will be available through the Engineers Ireland TV channel. So on engineersireland.ie afterwards, you will get that, and I think the slides will also be up there as well afterwards.
There was a question. So there was a question on if there is a following deep energy retrofits. So I think from end of 2020 or beginning of 2021, there is a process that after deep energy retrofit, you have to validate it, and that's by a third party. It's not necessarily the same contractor that has been doing the energy retrofits. So just to check that your indoor conditions, your energy requirements, they have met the goals.
Okay. There's a question here then around the individual grants. Are they available to do your labour yourself? I'll have to confirm that up, but in the past, you used to have to get the person that does the work. So let's say I want to get internal or external insulation on the house or an attic insulation, then I would have to get it done by an approved contractor, so somebody that is registered on the SEI website. So I'll have to check if that's changed or not, but that was the way. That's basically a single measure. The person that's doing that measure would have to be registered with the SEI website, or sorry, with SEI as a registered contractor to do the work. Yeah, someone's mentioned the one-stop shops are not yet listed by SEI. They were supposed to be listed this month. It's and someone here is saying that they're very difficult to get the one-stop shop to do the retrofit for 2 years. That's the problem, I suppose. It was mentioned there in terms of what the barriers are, and it's getting enough people that can do the work, skilled labourers, but also just that they're trained up well enough. So there's a whole heap of people need to be retrained in retrofitting and doing it proper and doing it correctly in that. And so the one-stop shops currently don't have enough capacity to meet the 50,000 homes a year, not to mind to do deep retrofitting. I think we were doing something around 2,000 or 3,000 homes of deep retrofitting a year around 2019 or so, or 20. So it's a long way that we have to go to get to 50,000. There's about 23,000 homes on average were retrofitted every year up to about 2019. But the vast majority of those were shallow retrofits. So you're kind of your single item or a number of item things, but not up to the B2 or better standard.
There is a question on BER ratings and air tightness. So is there any portion of BER ratings that look at air tightness?
Yeah. So Paul, will know more than I would on this. So within the BER, there's you have your air tightness test. So there's a default value in their BER, and then you can you do your air tightness test, and then you can put change that value within it was called the DEEP, which is the dwelling energy assessment procedure. So that's the procedure that's used, the standardized procedure that's used to get your building energy rating. So there's a default value, as I said, for the air tightness that you can use. I forget what it is. I think it's 5, is it, Paul? And then you do your air tightness test, and then you put in the actual value in there, and that will influence your BER. I don't know if you want to add anything to that, Paul.
Yeah, so it's dictated by the number of vents inside your home as well, and then if you have the number of chimneys inside your home, and then if you don't have an air tightness test, it calculates a default value based on that. But then if you have an air tightness test, it takes that value instead.
A question here on who can register as a one-stop shop and what qualifications do you need. I think you'll have to send an email to SEI and ask them that question. I don't think they actually specify that up on their website, but they have an email address that you can contact them if you're interested in registering as a one-stop shop. Okay, so I think we're just out of time. Just loads and loads of questions here I can see going through. I think a lot of them have been answered, or most of them have been answered already. There's one here I suppose I just want to pick up on in terms of the social housing side of things. I just see it coming up here. Obviously, the SEI are making some efforts in this regard in terms of people that might have more difficulty in terms of being able to fund the retrofit, so that they have the free energy upgrade side of things that will help in that. But all the local authorities are required under the Climate Action Plan to retrofit their homes. So all public buildings are due to be retrofitted to a B2 standard or better, I think by 2030. So that's a huge amount of work. That's not just homes and so on. So the government have ring-fenced grants every year to the local authorities. Every local authority gets a certain budget and has a target of or has a requirement to retrofit a minimum number of their housing stock every year in there. So so that's somewhat targeting that area. But again, you know, it's everything like in all of this, it's going way too slow. We need a lot more done quicker, but also ensuring that we have the right quality and so on. So for example, our own team are engaging with Galway City Council, measuring the performance of homes before and after they're retrofitted to help ensure that the correct retrofit measures are done on each individual unit, so that you have a good quality solution that will not just reduce the energy consumption of those homes, but also ensure that there's good air quality, good indoor environmental conditions for people that live in the homes. Okay, so I'm going to just leave it at that.
Just another plug on top of that, Jamie. Our colleague Orla is carrying out surveys with homeowners who have kind of gone through the entire retrofit process themselves, kind of gathering their thoughts on the whole experience. So if anybody here would be interested in kind of getting involved with that, feel free to contact either myself or any of us, and we'll get you in touch with Orla.
Yeah, thanks, Paul. So there's Orla's email address. Orla, that's not actually her right email address. It's orla.mcginley2 at nuigalway.ie. Or Paul or myself, we'll pass it on to Orla as well in there. So with that, I think I'm going to close the session.